Now, the next example is the sequence n over 2n plus 1. If we're going to write the elements of the sequence, we have 1/3, 2/5, 3/7, and 4 over 9 as the first four sequence terms of n over 2n plus 1. That is, if n is equals to 1, we have 1/3. If n is equals to 2, we have 2/5 as the second term. If n is equals to 3, the third term is 3 over 7. And if n is equal to 4, the fourth sequence term is 4 over 9. Now take note that from the first term 1/3, the next term to it is 2/5. From 2/5, the next term to it is 3 over 7. From 3 over 7, the next term to it is 4 over 9. Now to get the rest of the sequence term, we have to find the general expressions for the rest of the sequence terms. Now if we let 1/3 to be as n over 2n plus 1, now considering that the next term is 2/5, if we're going to add 1 to 1, then this becomes 2. If we're going to add 2 in 3, then this becomes 5. Therefore, we can also say that for n over 2n plus 1 to become 2/5, we can simply add 1 to n, and we will add 2 in 2n plus 1. This can be simplified as n plus 1 all over 2n plus 3. Now let's see if this is the same as to the rest of the sequence terms. So if 2/5 is equal to n over 2n plus 1, now the next term of 2/5 is 3 over 7. Now for 2 to become 3, we can simply add 1. From 5 to be 7, we can simply add 2 in 5. Hence, we can also add 1 in n, and we can also add 2 in 2n plus 1. This one. And then, same as with 3 over 7, 4 over 9. For 3 to become 4, we add 1. For 7 to become 9, we add also 2. Hence, we can also add 1 here and 2 here. Therefore, since all of the sequence terms are true, I mean, the next term of n over 2n plus 1 is written as n plus 1 over 2n plus 3. Therefore, we can say that the next sequence term are in this expression. So n over 2n plus 1, and the next term to it is n plus 1 over 2n plus 3. Now observe that the first term 1/3, the value of 1/3 is less than 2/5. 2/5 is less than 3 over 7. 3 over 7 is less than 4 over 9. What does it imply? It implies that the elements increases as the number of terms increases. Again, the elements increases as n increases. Okay? So in general, we can also say that the term, like the first term or the previous term, is less than to its next term. Okay? Remember, this is our n over 2n plus 1, and this is our n plus 1 over 2n plus 3. Therefore, we can say that the previous term is or the latter term is less than to its next term. Hence, in general, we can say that n over 2n plus 1 is less than or equal to n plus 1 over 2n plus 3. Now, let us verify the inequality. Okay. We may verify it by cross-multiply first. So we have n times 2n plus 3, and then n plus 1 times 2n plus 1. And to simplify this, we have 2n squared plus 3n, and on the other side, it's 2n squared plus 3n plus 1. Take note that this is 2n squared plus 3n, and this is also 2n squared plus 3n. So they are equal. However, on the right side, we have plus 1. So this means that the left side of the inequality is less than to the right side, to the value of the right, in the right side, the expression at the right side of the inequality. Okay? Since we verified that this inequality holds, we can say that this inequality holds. Therefore, by definition, the term an is less than, since an is less than or equal to its next term, then we can say that the sequence n over 2n plus 1 is monotonically increasing.